Good morning. Myself Srihari and I am the developer of Aegis AI, Autonomous Smart Home Guardian made for the Arduino Physical AI Challenge India 2026. Arduino is an AI-powered smart home guardian that combines real-time sensing, intelligent decision-making, automation, and hardware integration to make a home safer, smarter, and much more responsive in real-life situations. A traditional smart home usually follows fixed rules. For example, if a motion is detected, turn on light. But the same motion means that someone is at home, someone just entered unexpectedly, or the user simply needs a light. Aegis is designed to consider the current situation of the home. There are four modes which I will talk later before deciding what should happen. It can monitor things temperature using the DST sensor. Is there a gas leak using MQ2 sensor, light intensity using the IR, and the movement using the PIR sensor. This is the hall. It has like 3 LEDs, a DST for temperature, a LDR for the light intensity, a PIR for temperature. This is the kitchen area. There is 2 LED, a MQ2 gas sensor for detecting the gas leak, air quality and all. And this is the bedroom. There is also a LDR, 3 LEDs, a PIR to detect the motion. Also, there is a garage where there is a servo used as a gate which can be controlled through the dashboard. The primary competition board is Arduino UNO Q, but Aegis also uses Arduino Nano as the I/O expansion board controller. Arduino Nano gives additional Arduino Nano handles sensor data and output connections, while the Arduino UNO Q handles AI, decision making, and sends all the commands. Arduino UNO is a Linux-based SBC single board computer, so it uses the UTAR serial communication to communicate to the Arduino Nano, and it sends serial commands, and through that only they are communicating. This separation allows Aegis to support more hardware without changing the role of the main controller. The sensor provides live information every 2 seconds to the Arduino UNO Q, which is the software, and the Arduino UNO Q sends the serial command back to the Arduino Nano to change the home things. The most important part of Aegis is not simply turning devices on or off. It is the decision system, the AI of the Aegis. Aegis combines 3 important systems: user intent, live sensor information, and the current state of the house. For example, if a user asks, "Is my house safe?" Aegis don't just simply say yes or no. It can consider the current home situation, state, and relevant sensor information before producing a response. If the user says turn on the hall light, the request is interrupted, converted into commands, and then the Arduino UNO Q sends a serial command to the Arduino Nano which turns on the light. Now let's look at some live demonstrations. And okay, this is the house model. Here I will open the Aegis dashboard, and this is the dashboard where we can see like there are like quick controls. In the bottom we have zone monitoring. Here hall lights are off, there is motion. Bedroom lights off, motion. Kitchen lights off, gas is safe. Main door IR. I actually planned to add a IR to the main door, but because of the time I couldn't complete it, so I removed it. Also the garage, the servo as we see. And the bottom we can see some important sensor details like the temperature, which is 29.0 degrees Celsius, the humidity, which is like 84, the gas quality, and the whole motion which is detected. Also you can see here this refreshes every 2 seconds. Okay, sorry. Now let's go to the next page, this controls page. In the controls page we will be controlling the home. You have these cards, they are like hall lights. Now all the lights in the Aegis are turned off, so like let's turn on this hall light. 1 second. Okay, after clicking you can see that the light have turned on only in the hall. Now let's turn on the bedroom light, which is this room, and this has been turned on. Now let's turn off hall, and like I will press the button. Okay, and the light has been turned on. Now I will press the bedroom light turning off button, and yeah, the light has been turned off. Now let's also turn on like the kitchen light, and we can see like the kitchen light is also turned on. And let's turn off, and it works just the same. Now let's try like turning on the servo, which is the gate to the garage. Like we can click the button, and okay, okay, now we can try turning on the garage door. Can click it. As you can see, the garage has turned on. Now I will click the button. I will focus the camera on the server so you can see. Garage close, and you can see the garage servo has been closed. And the bottom there we can see the automation. There are 4 modes: normal, night, away, and manual. When the motion is detected under the configured situation like normal, night, away, or manual, Aegis can activate the appropriate lighting based on the rules and the things we teach the AI. After the configured period without motion, the automation can return the lighting to its previous state. If the user has turned off the light, and because a motion and the house settings was just right, it turned on the light. After a specific time, the AI will automatically off the light or change it to the previous state. Also, the LDRs helps to reduce the electricity bill by turning off the light when not needed, or the room has enough light. These can be also controlled by using the natural language, which is a chat. So okay, this is our dashboard. Okay, before that I will show the sensors page. Here we get the detailed view of our sensor, like the hall temperature, humidity, hall brightness, hall motion, bedroom brightness, bedroom motion, air quality, gas, kitchen gas, main door, servo, and the buzzer. Only that much is there. Next is the event space. This here we can see every single thing that has done in the house. Like if automation has turned on the light, it will be here. If the user turned on the light, then it will be here. Anyone entered the room, like a motion, then we can see like the motion detected just like that. Now let's go to the chatbot section. Okay, here next is the chatbot section. Here is a chatbot based UI. To start off, like okay, I'll just refresh to okay, there are some messages, so I'll just refresh to remove those, and let's start new. Okay, this is the chatbot, and to start off, okay, I will say hi. I think the internet is a bit slow, that is why it is taking time. It was quick. Let's try refreshing the software. Okay, now let's open the chat and ask okay, hi. Okay, now it's worked. Hello, I'm Aegis, your AI Smart Home Guardian. Now let's ask a question like to turn on the light, like that. So let's ask turn on the hall light. Okay, let's ask turn on the hall lights. So I have sent the message turning on hall light. Aegis has responded and the lights have been turned on. So now we can ask like, is the house safe? Is the house safe? Yes, the house is safe. AI in the background has done all the things such as reading the sensor values and all the other things. Now let's ask it how many lights are turned in. Currently there are only one light has been turned on in only in the hall. So let's ask it how many lights are turned on. Send it, and one light is currently on. Okay, that is just right. Just like that, it can be remotely controlled as a chatbot or as through the UI, or not just house things. It can even answer GK and other things. Okay, let's ask what is 11 into 10. Okay, the answer is here. You can ask another question like what is the capital of India? Okay, I have asked the question what is capital of India. The capital of India is New Delhi. Just like that, you can answer any sort of questions, including the questions in the house. Aegis also prioritize safety related events. If the system detects a danger such as a gas leak, someone just entered the house, then the automation layer can prioritize the safety response over normal automation. The goal is to make the home capable of reacting automation instead of waiting for the user. That is why we added a buzzer to alert the user and also notify the user. There are many smart homes in the industry, but the problem with many smart homes are they mostly only rely on like role based, or other smart homes like Alexa, they need to be connected or they need smart devices. But what Aegis solve here is at the construction of the house or even after the construction of the house, Aegis can be easily added to the house. And not only that, it can control any device with no other problems. It can even give sensor information. The software interprets the home state, they understands the user intent, and the automation system evaluate the configuration rule, and the control layer performs the required actions. And this is how the main idea behind the Aegis. The system is also designed to be expandable. Like I said, this is not the limit. We can add IR. If we want, we can add a CCTV. If we want, we can add like fan, AC, TV, anything can possibly think of. We can add that to the house. There is no limit for it and can be easily added. For the future, this is actually Aegis V version 1.0, and this is the MVP. The next version will have a more advanced layer of automation and offline support, which we will be using Bluetooth to connect to the surroundings with protection, so no other person can use it. Also, we'll be adding energy monitorization, occupancy prediction, additional security, camera based intelligence as CCTVs when connecting, and other forms of intelligent house system. The architecture is designed so that new hardware can be easily added, as I said. To summarize, Aegis AI combines artificial intelligence, embedded hardware, and real-time sensing information into one smart home. It senses the environment, checks the house state, interprets the user message, makes decision within its system configured rules, and controls the physical system. This project was this project was developed by me, Srihari SA, for the Arduino Physical AI Challenge India 2026. Thank you for watching. This is Aegis AI, the autonomous smart home guardian. Thank you and have a nice day.